So let's start with 2, 4. Now, in 2.4, remember 2.4 is graphing of those inequalities. So we know that strictly less than and strictly greater than, when we go to graph them, they're going to get a dotted line. Greater than or equal to, less than or equal to, those again are going to get a solid line. Right? So make sure you remember that. Very, very important. And then what do? Well, we need to go through and we need to check a point that is not on the line. And usually what we check is we check 0, 0. If 0, 0 is on the line, then we just pick another point, usually like 1, 0 or 0, 1, something like that. So let's look now at question 5, just to make sure we remember how to graph these. So what we have is we have 2x plus y is less than or equal to 4. So what we need to do is we need to graph it. So this is our original, and this is what we're going to be checking in. So I'm just going to box it so we don't lose it. But let's go ahead and solve that for y. So move that 2x over. And now we've got y equals a minus 2x plus 4. Now we should kind of know how to graph this, because what's our slope? Okay, our slope is a minus 2 over 1. So down 2 and over 1. And the y-intercept is the b component. And the y-intercept as an ordered pair is 0, 4. So when we come to these, what do we need to do? We need to solve it for y. It needs to be in slope-intercept form so that we can graph it. Now, this one is less than or equal to, so it is going to get a solid line. And we're going to start at 0, 4. And 0, 4 is clear up here. So right there is where we start. And what is my slope? Okay, my slope is down 2, so down 2 units, and then over 1 unit. So we're going to go down 2, and then we're going to go over 1, and we're going to make a new dot there, right down from this point here. This is where you started at. We went down 2, over 1. Now, because it is less than or equal to, it is going to get a solid line. Is everyone okay with that so far? So we solved it for y. We found our slope. Okay, we graphed that line. Now, it is an inequality, so what do we need to do? Well, we need to check the 0, 0. So let's check 0, 0 back in the original. So we plug the 0, 0 back in. 0, 0 went in here. And then what does that give you? Well, that gives you 0 is less than or equal to 4. Is 0 smaller than 4 in this case? 0 is smaller than 4, right? So 0 is clearly smaller than 4, so that would be true. So that means this half is true. The line separates the two regions, so the upper half is false. And where do we shade now? We shade where? We shade the true part. So we're going to be shading here. So that is what your graph will look like. So don't try to make these more difficult than what they need to be. Now, question 9, you already have the graph. So it's actually substantially easier. So there's your picture there for that was 5. We're now going to look at 9. Now for 9, they already gave you the picture. And it looks similar to this. And they give you 2x plus 4y is less than or equal to 8. So on this one, 90% of the work has already been done. Right? So there's not a lot to do. all we need to do on question 9 is figure out and determine where to shade. Okay, so what do we check? When we have a line like this is an inequality. We need to pick and start with 0, 0. It's not on that line. So we're going to check 0, 0. And we check that back in our original. And then we see if it's true or false. So the left-hand side is nice because it comes out to be 0. The right-hand side is 8. And is 8 larger than 0? Yep, it's clearly opening towards a larger 1. So that means 8 is larger than 0. That is true. The line splits it in half. So this half is true, this half is false. Where do we shade? We shade the true half, which in this case is going to be below the line. And that's it. There are a couple of them like this, and there are a couple of them like 5 as well. But I wanted to just kind of go over more of them just to get you a nice review. We do have a couple of quick questions out of 2.5. Then we'll move on to 2.6, which is a quick, easy section. And then we'll break up into groups and work on our practice exam. Okay, so let's look now at 2.5. Let's look at question 7. So 2.5, we're going to look here at question 7. And these are determining if it's a function or not, and then giving the domain. So for question 7, we've got y equals 4 over x plus 18, right? Now, what do we need to make sure that we don't have? There are two things when we look at the domains. No division by 0, okay, and no square roots. Well, we don't have any square roots to worry about, but we do have the possibility of division by 0. Because we need to figure out what number is going to make this denominator right here 0. So what we do is we take our denominator, which is x plus 18, and we set that equal to 0, and we solve it, and we get negative 18. Now, why is negative 18 not a potential solution? And that's what the domain is. Domain is potential solutions. Okay, why is negative 18 not a potential solution? Because if I plug in negative 18, I get negative and positive 18. They cancel. And can you take 4 and can you divide it by 0? No. So negative 18 cannot work. When you find the domain, you are listing out values that could work, could possibly be solutions. So we need to figure out which numbers cannot work. And we need to make sure our square roots are positive underneath. And we need to make sure that we don't induce division by 0. So how do we write our domain? Well, this is how we would write it. And our domain is negative infinity to negative 18. We use parentheses on both. We use a union, negative 18 to positive infinity. And this one, by the way, is a function. So that one is clearly a function. Now, what's the difference between 7 and 10? You're going to have different solutions. Okay, so this one we couldn't use negative 18 because it would give you division by 0. But what about question 10? Well, question 10 is y equals x plus 7 over 11. Now, how is this one different? Well, on this one, x is not in the denominator. Right? So x is not in the denominator. So we can never have division by 0. So if there's no possibility of division by 0, then your domain is all numbers, and we represent that by negative to positive infinity. Okay, because there's nothing that I can ever plug in that's going to give me division by 0. I can plug in 11, okay, because 11 plus 17, or 7, that's 18. Over 11, that's fine. 0. 0 plus 7 is 7. Over 11, still okay. Never can you get division by 0. So if x is not in the denominator, then it is all real numbers, or negative to positive infinity. Do you see the difference now? Right? So this one has x down below, and this one does not. So does that now take care of the questions out of 2.5? Did we have any more to look at? If we don't have any more, then we now will go ahead and look at 2.6. In 2.6, we're going to be talking about function notation. So for function notation, we can have things like f of x, g of x, h of x. These are called functions, and they can replace the y. So we can replace y with any of these, okay, because these are called functions. Now, in a later chapter of this textbook, we're going to focus more on them, and we'll learn how to add functions, subtract functions, multiply, and divide. But in this section, all we're doing is we're just introducing the concepts of functions. And functions are very, very easy to work with. So the first thing we're going to learn how to do is we're going to learn how to plug numbers in to functions. So I'm going to give you a function, and we're going to plug a number in. So I'm going to give you f of x, let's say, is 5x minus 8. And I want you to find, with this function, how about f of negative 9? Now, what does it mean if I give you f of negative 9? Well, this negative 9, what happens with it is it's going to replace that value of x. So we just rewrite our function with parentheses for the x, and then we replace the x with, now, negative 9. And then we can go ahead and multiply through and combine. So negative 9 times positive 5, that's a negative 45, minus 8. Putting those together, that gives you then a, what, negative 53, isn't it? Yep, negative 53. And that's your answer, and that is f of negative 9. So f of negative 9 is a negative 53. All we did was we plugged the number in that I give you. So let's do another one. I'll give you a different function. How about you're given h of x equals 4x squared minus 7x plus 9. And how about we try to find f of negative 3? So we want to find f of negative 3 here. So what we're going to do is we're going to plug in that negative 3. And then we're going to see what we're left with from there. So let's plug in that negative 3. So I'd like to just rewrite it with parentheses wherever there's an x. So we'll just use parentheses. And what goes inside of our parentheses? In this case, we use a negative 3. Now, we do have to be careful because when we work with these, we square. And when we square a negative, what does it become? Okay, when we square a negative, it becomes a positive 9 there, right? So that negative 3 becomes a positive 9 when you square it. And then let's do our multiplication. 4 times 9 is a 36. Negative and negative makes it a positive 21. And then we'll add 9 to that. So that's going to be then 66, I believe. Yep, because there's 36 plus 30 should make that then 66. 1 plus 9, yep, 66. And that is your answer. Oh, sorry, that should be an H there instead of an F. But that means your H of, in this case, negative 3 is your 66 there. So all we did, right, and this should be an H here. That way it matches with that one. But all we did was we plugged that number in. That's it. Now you can also plug in variables. We'll do the variables and then we'll come back and we'll look at a fraction when we plug a fraction. Right, so let's now try some with variables. And let's say you're given f of x to be 5x minus 3. And I want you to find f of k minus 5. Now, how would this work? Well, this k minus 5, all right, that is going to replace the x everywhere. So we work it out exactly the same as the others. We plug in that k minus 5, and then we simplify it down a bit. So let's see what we now have. Okay, if I plug in that k minus 5, I have 5 out in front. Use your parentheses for the x. Minus 3. And what goes inside of the parentheses? That's going to be k minus 5 there, isn't it? And what do we do next? We just simply distribute through that 5. And that leaves you with 5k minus 25 minus 3. So now we have 5k minus 28. And that is your f of k minus 5 there. Right? So we just plug our value in. Now, let's try another one. This one we're going to have to square. So we only have a couple more questions from this section to look at. There's very little to actually do in this section. There's only 3 topics, and right now we're doing one of them. Then we have to write things in function notation next, and then graph them, and that'll be it. That'll be the end of this. So let's do another one. Now this one we are going to have to FOIL. So let's say you're given h of x equals 3x squared minus 2x plus 5. And I want you to find h of, I'll use the same variable that I did in the homework. That way it's easier to keep track of. How about we use, we'll do the same thing. How about h of k minus 1? I'm trying to make it very similar to what's in the homework. Okay. Last time we did k minus 5. The one in your homework's actually got k minus 1, so I'm going to use a k minus 1. And again, parentheses for the x. And then what do we replace the parentheses with? Well, what's inside of our parentheses? Inside of our parentheses is a k minus 1. So we're going to plug that in. Now this is going to kind of be a review and build up to what we're going to be doing next. So after this chapter, when we do the graphing, then we look at systems, and then right after that, we start talking about polynomials and how to multiply them together and FOIL and factor. So we're going to go ahead and work with this. Now, we need to do our exponents first. So let's go ahead and work it out. So how would I handle k minus 1 quantity squared? Well, the way I handle that is I rewrite that as k minus 1, k minus 1, and you probably have heard of this before. We're going to FOIL. Okay, so we take that k minus 1 here. We're going to write it out twice because that's what it is, and we're going to FOIL. So how do we FOIL? We take the first times the first. First times the first is k times k, and that's a k squared. Outside times outside, that's a k times a minus 1, so that's a minus k. Inside and inside, that's another minus k. And then finally, we have last times last, and negative makes it a positive 1. Combining those together, we get now k squared minus 2k plus 1. So now we'll rewrite this as this. This is the most difficult question that you're going to have. There's only one of them, and they're really not bad to do once you see how to approach them. So this is what we have right here. Okay, so I just took this, and I wrote it out, and I FOILed, and I got to here. Now, last step, distribute that 3 through, bless you, and distribute this negative 2 through. Do what? This is going to be very, very similar to question number 8 in your homework. Different numbers, right? But it's very, very similar. So this one, a little bit different, but it is very, very similar to question 8. Just different numbers is all it is. So I try to make it as close as possible. That way you kind of see what to do. Now, when we distribute through, we get 3k squared. 3 times a negative 2, that's a minus 6k. 3 times 1, that's a 3. And then we have a minus k. Double negative makes it a positive 2. And then we have our 5. And now we clean it up. And so we have h of k minus 1. And we clean it up. So highest power goes first. So that's a 3k squared. Gone there. Minus 6k and a minus 2k. That makes it a minus 8k. Gone. Gone. And then we have 3 plus 2. That's 5. Plus 5 more than makes it 10. So that will be your final answer on that one. And that is going to be very, very similar to question 8. Not exactly the same, but very, very similar. We can also plug a fraction in. So let's try one of these where we have to work with a fraction. And this is like question number 1. They're just different numbers is all. So you're given your f of x to be 2x squared plus 3x minus 1. And I want you to find, how about f of 1/2? A lot of times, students get nervous when we see fractions. And we're going to work with them over the side, and we're going to combine them together. We cannot get rid of them. We have to work with them. They're not difficult if you're careful with them. So I'm going to plug in a 1/2 for the x there. Now, on question 1 from your homework, it's a little bit different, but not much. Because question 1, and if you look here, question 1, you plug in a 1/4. Instead of a 1/2, you plug in a 1/4 or 1/4. So same, a little bit different. How do we work with this? Well, we need to do our exponents first. Remember, that's our first rule. And how do I square the fraction? Well, a half squared is a half times a half. And I simply multiply 1 times 1 is 1. 2 times 2 is 4. So I plug that 1/4 in because I took that 1/2, I wrote it over the side, and I squared it. Is everyone okay with that? You just square that fraction out. Now what do we need to do? Well, now we can multiply. So 2 times 1, that's a 2 over 4. We'll reduce it in a moment. 3 times 1, that's a 3 over 2. We've got a minus 1. Well, what about 2 over 4? 2 over 4, that's going to reduce down to be a half, right? Because that's what 2 over 4 reduces down to. And then we've got 3 halves, and then we have a minus 1. And what about a half and 3/4? Okay, we can just add these. Remember, these fractions can go together. And that's 4 over 2 minus 1. And don't make it harder than it needs to be. What's 4 over 2? Right? 4 divided by 2 is a 2, right? And 2 minus 1 makes it then a 1. So your final answer there would just simply be a 1. Again, not bad. You could have skipped steps. You could have done a lot of this in your mind because you could have mentally saw that 2/4 is 1/2. These can go together, and then you could have saw that 4 over 2, well, you could have just mentally reduced that down to 2. It's the same thing. Or you can write out the intermediate steps and work it out. But that's going to be just like question 1. Different numbers is all. We've got two more quick topics to go through. And the directions for the next one are going to be solve for the variable x. Variable y. My mistake here. So we're going to solve for the variable y. And we're going to replace y with f of x. So what we're going to be doing is we're going to solve this equation for y, and then we're going to take that y and we're going to replace it with your function notation f of x. And this is like 2 and 3. So this is what we're going to be doing. So I'm going to give you a function, and we're going to solve it for y and replace y with f of x. There's not much to these. So let's say I give you, how about 3x plus 2y equals 7. So right now it's in standard form, okay? And what we want to do is we want to basically get this in slope-intercept form so that we could then replace that y with your function notation. So let's move that 3x over. And now we've got 2y equals a minus 3x plus 7. We're going to divide that by our 2. And now we have y equals a minus 3/2 x plus 7/2. And what we want to do is we want to replace that y with f of x. So it then becomes, for your final answer, f of x equals a minus 3/2 x plus 7/2. Let's do one more, then we'll graph them, and then I'll do a homework question, or set up a homework question. So same directions as the previous one. about we make this one pretty easy? How about 5x squared plus y equals 9? Little bit different from what you got in your homework, but still very similar. And let's put a 7 in front of here. So let's just put a 7 in front of that. Okay, so 5x squared plus 7y equals 9. We do the same procedure. So move that 5x squared over, same direction, same procedure. So 7y equals now a minus 5x squared plus 9. We divide by our 7. And that leaves you with y equals now minus 5/7 x squared plus 9x. And we, for our final answer, we replace f of x with that y. So we replace that f of x with y. Okay. Now, how do we graph them? Well, when we go to graph them, they're actually very easy, because when we go to graph these, they're already solved for y, basically. They're a function, all right, and function, that f of x and h of x, that's the same as y. So we're going to graph these. We're also going to find the domain and range. So we're going to graph these, and then we're going to find our domain and our range. And we'll do 2 of these. How about I give you g of x equals, well, let's say 3x. So I want you to graph this. Now, very easy to do. This is one of the easiest ones we've done. This g of x, well, that g of x is the same as y. So g of x, f of x, any function is the same as y. And it can be used in place of y when we go to graph these. Now, how would we graph this? Well, this one has been solved for y, and the 3, well, that represents your slope. So that's a 3 over 1. There's no number on the end, so we add in that 0, 0. So what's our y-intercept? Our y-intercept is 0, 0. So how would we graph this? Well, where do we start at? Start at the origin, 0, 0. And then what's my slope? 3 over 1. So we go up 3. And then forward 1. Make our new dot. Connect them together. There's your line. And all lines have the same domain and range, because they can go up and down, left and right. So my domain, we use a D to represent the domain. Domain is values of x, so that's negative to positive infinity. And the range is values of y, and that's also negative to positive infinity. Why is that? Because it can go up and to the right, and down and to the left. So left and right, up and down. That's why it's negative to positive infinity. One more, and then I'll set up question 6 for you. So again, we're going to graph this one. And we're also going to find our domain and our range. Well, what do we know about f of x? F of x is treated the same as y. We use f of x because sometimes it's easier. So we'll replace that f of x with the y, which is what it is. So my slope is a half. So that's up 1 over 2. And this is your y-intercept. And that's 0, 5. So 0, 5 would be here. 1, 2, 3, 4, 5. And then what do I do with my slope? Well, we go up 1. And then we go over 2. So up 1, over 2. Connect it together. There's my line. And all lines have the same, all diagonal lines have the same domain and range. And the domain, we represent that with a D. And that's negative to positive infinity. And the range, we represent that with an R. And that would also be negative to positive infinity. And I'm now going to help set up and get you started with question 6. There's only one application in your homework to look at. So we're going to look now at question 6. So what we're looking at is we're looking at modeling the number of appliances sold. So question 6 says, suppose the sales of a particular brand of appliance are modeled after this linear function, S of x, where S of x represents the sales in year x, with x equaling 0 corresponding with 1982. So we want to find 1993. So here's our function. So S of x equals 120x plus 4,800. Okay, yep, so this is going to be question 6 of your homework. And this is 2.6. And we'll break up into groups here in just a minute. Now, we need to figure out the pattern. And here's how it starts. So x equals 0, well, that represents 1982. X equals 1 goes with 1983. X equals 2, well, that would be 1984. And we'll do one more, and then we'll figure out the number we're going to plug in. So x equals 3 would be 1985. And continuing this pattern, we want 1993. And so 1993 would be what? 1993 would be, well, if you look here, 83 to 93, that's a difference of 10 years. Okay, add 1 because it's 1. And so x is going to be what now? 11. See the pattern? Add 1 every time. Go all the way down to 1993. And here's what you want to find. You want to find this. You want to plug in that 11. So you're going to find now S of 11. And that is 120 times 11 plus 4,800. And you can finish it from here. So you go ahead and finish it from there. Now we're going to break up into groups. And there's 6 of them.